Hi, my name is Ms. Pucci, and welcome back to our unit on inventors. Today we're going to be talking about the inventors of science and medicine. Keep an eye on our background for today and consider, what do you think we're going to be talking about today? Let's hit those lesson objectives. Today, of course, we're going to be able to identify some key inventors, and we're going to be able to connect them to their most important and impactful inventions, but most importantly, we're going to talk about how those inventions affected daily life and history as a whole. We're going to talk about who those inventions impacted and why they were important. So, let's meet our inventors for today. We're going to be talking about Antony von Leeuwenhoek in the 1600s. 100 years later, we have Edward Jenner. And then we're going to take a pause after them, and we are going to address a huge controversy in science and medicine with Watson and Crick versus Rosalind Franklin. And that happened in the 20th century. So, put a hold on that, and we'll get to them at the end. Let's start with Antony von Leeuwenhoek. He was born in 1632 in the Netherlands, and he lived until 1623, so he lived a pretty long life, and he was a biologist. Whenever he was a teenager, he actually worked in a linen store or a linen factory, and as you can see here, this is just an example picture of a really zoomed-in shirt. He became interested in his field of study known as microbiology, because he would look really, really closely at the individual threads on the linens, and he would count them using a magnifying glass. Can you imagine how long that would take? Just look down at your shirt right now and think how long it would take to count each individual thread. But either way, this is where Leeuwenhoek found his interest in what is now known as microbiology. So let me show you here. There we go. Oops. There we go. So, Leeuwenhoek's most notable inventions and discoveries start with the microscope. However, he did not invent the microscope, kind of like how Nikola Tesla improved the alternating current, but he didn't invent it. That's what Leeuwenhoek did here. He didn't invent the microscope, but he made improvements on it. And that is in the top right corner of your screen. It's way different than what you expect a microscope to look like today. On the right side of your screen here, you can see what you might expect a microscope to look like. That is what they look like today. Of course, Leeuwenhoek had a very early model of it, but the technology inside of it has definitely stood the test of time, and it was definitely top tier for whenever he was researching. He also invented microbiology, which is the study of really, really, really tiny living things. He studied protozoa and bacteria, which are super, super tiny. Obviously, whenever you wash your hands, you know how you're washing off bacteria? That's what we're talking about. Protozoa are just other tiny creatures that are the same size. He also invented a lot of microscopic lenses that range anywhere from 50 to 300 times the size. So you could zoom in that far, which is super cool and was definitely unheard of for the time. He also studied the structures of insects and plants at the microscopic level, and he was the first person to give us an accurate description of red blood cells. So you can see right here, there's a little drawing that he did. Those were his notes and his handwriting of red blood cells. And then further to the right, the other picture is a more modern look of what we see red blood cells to look like. So as you can see, he was very, very close. So this, obviously you think like, okay, he made the microscope, so what? This opens us up to so much leeway for invention and discovery in medicine. Because even though we're just seeing things, we're able to see them and study them and discover how they work. And then maybe we can even design new things to interact with the little tiny things that we can't see with the naked eye to help other people. So this just opened up a whole new field of research that wasn't available to them before. Now let's move on to Edward Jenner. I'm going to move myself back up here, maybe? Yeah. Edward Jenner was born in 1749 in England. I showed you a little map down here. This blue area is where we are in the United States of America. This red circle is representative of England, and then this is just England super zoomed up. This little red area down here was actually where he lived. Edward Jenner was actually a surgeon. He lived from 1749 to 1823. And I'm about to give away what he discovered, but Jenner was really, really ridiculed for his research. People made fun of him a lot and said that the vaccine was repulsive. And I know you're probably thinking, how is the vaccine so repulsive? Well, let's take a look and find out why people might have thought that was true at the time. As I've already mentioned, Edward Jenner discovered the vaccine, most notably the smallpox vaccine. I should note here I made a mistake. This should be highlighted for you, so make sure that this is something that you commit to memory. Now let's watch a little video about how Edward Jenner came to discover the vaccine.
This is the smallpox virus. It infected the pharaohs, caused a terrible impact on the Greek and Roman empires, and decimated Native American populations. Nothing seemed to stop this lethal plague until the end of the 18th century. At that time, smallpox was a major global endemic disease. Only in Europe, it killed around 400,000 people per year. It didn't differentiate between rich and poor. Even 5 kings were killed. But for some reason, milkmaids and shepherdesses seemed to be immune to the disease. In fact, they were renowned for their beauty because they...
Okay, so let's pause here for 1 second. Let's just articulate what the problem here is, because this is a great example of how an invention was used to solve a specific problem. We have the smallpox. Smallpox was affecting everybody, ever since ancient times. Remember when they mentioned way back to ancient Egypt and ancient Romans? Affecting people even to what was then the modern day kings and queens. That is really problematic because no one could avoid it. But we're saying here that Edward Jenner might have noticed something in the common milkmaid, the person who would just milk cows. They're saying that for some reason she wasn't being affected by the smallpox. And in fact, people often would look onto the milkmaids with this just kind of admiration because their skin was so pretty because they didn't have all the lesions and the marks from the smallpox. Interesting. Let's find out maybe what Edward Jenner would have done with this information.
Their skins were free of the scars smallpox caused. They were attractive and resistant. But why? That's what the rural doctor Edward Jenner was trying to understand. He knew that milkmaids got small blisters on their hands when they milked cows suffering from cowpox, a mild disease that cattle suffered from, which caused similar lesions to smallpox. And this phenomenon made Jenner think that maybe cowpox and smallpox were related, and that infection with the milder disease would be enough to protect people against the lethal one. As a man of science, he decided to prove it, and to do this,
Okay, so let's recap again. So he saw that, okay, the milkmaids weren't totally safe. They would get lesions on their hands, but only from the cows who were suffering from cowpox. They still weren't getting smallpox. So then he's wondering, I wonder if I were to inject someone with that disease, if the milkmaids were exposed to it so much, if they were just familiar with it, if he were to inject someone with that disease, how they would be affected by it. So let's look at his experiment.
He needed 3 things: cowpox that he extracted from a milkmaid, fresh smallpox from a patient, and a human guinea pig. He chose his gardener's son, an 8-year-old boy called James Phipps. He infected the child with cowpox, waited a couple of months, and injected him with smallpox. And James didn't become ill. He repeated.
Okay. So I'm going to stop the video there. So what he did was he took a little bit of the cowpox and he took a little bit of the smallpox, and then he injected it a couple months apart into the boy's arms, and he didn't get sick with either of them. Here's why, and here's how it works. So whenever you inject just a little bit, it's enough that your body has enough antibodies to fight it off. And now they can recognize it and see, okay, the next time we see this thing, we know how to fight it off. So that way, if that little boy ever came in contact with smallpox or cowpox again, the body would know how to fight it off. And that's how the common vaccine works, and that's how they still work today. So, here's some fun facts about the vaccine. It was named vaccine after the Latin word vacca for cow because of the cowpox discovery, and now because of the vaccine, smallpox is completely eradicated. It is gone. Nobody today gets smallpox because of this vaccine. So why did people find it so repulsive? Well, they didn't understand the science behind it. And so they thought it was really gross to be injected with smallpox or cowpox, which, it makes sense. So at the time, that is why, but now you know why it is actually really, really smart. So let's continue on. Let's get controversial. Now we're down to our last few people. We are going to set Leeuwenhoek and we are going to set Edward Jenner aside, and now we're going to talk about one of the biggest controversies in science of the 20th century. Who really invented the double helix? Here is the tea, or the gossip. Watson and Crick published the double helix, but Franklin says it's hers. Hold on a second. I have a lot of questions here. What's the double helix? Who are Watson and Crick? And who is Franklin? Let's stop and do some more research before we read the facts. First, I'm going to do a quick Google search. I just searched, what is the double helix? Now, if I were you, I would search to find some more reliable websites. However, I know this information, and I know that Google hooked us up here with some pretty good information, so I'm going to give it to you. The double helix is just the structure of our DNA, or the genetic product that is in our body. It has all the codes and everything to tell us who we are, what we're made of, what diseases we could have, what genes we have, how we look, all that stuff is all in our DNA, and it is cased in a little structure called the double helix. And it looks like this. It's this little spirally ladder-looking thing. So that is all the double helix is. Now let's talk about the people who are involved. Watson and Crick worked together. They were both born in the early 1900s, and they did a lot of biomedical research together. Just life medicine. They just did that kind of research. And their claim to fame is that they identified that double helix structure. They say that they found it. However, Rosalind Franklin, born at the same time, was a chemist, worked separate from them. She says that that is her claim to fame too. So who really did it? Well, here are the facts. In 1946, Franklin worked in a lab in Paris, where she was taught something that's called X-ray diffraction. Basically, whenever you look through an X-ray, the reason why you can see your bones is because it sends the X-ray light through it. The bone blocks it, so it ends up being a solid source in the middle there, and the light goes past the rest of it. So it kind of cuts out everything like a little stencil and just leaves your bone able to see because the bone is too dense for it to go through. So she was using these tools to look at other things, not just bones, and she was able to create images of tiny, tiny solids rather than just really fuzzy little crystals. So she was working towards this discovery. In 1951, she finally caught the photo of the diffraction of DNA. It is known as photograph 51, and I'll show that to you in a second. But it took her 100 hours of exposure to X-ray to get it. Uh-oh. On another note, in 1953, one of her colleagues, who didn't like her, ended up giving that photograph to Watson and Crick at another institution just because he didn't like Franklin. So then, as soon as Watson and Crick saw it, they knew exactly what it meant. That X-ray diffraction photo told them immediately what the structure of the double helix looked like, so they drew up a model, they published it, and they gave it the tiniest little bit of credit with a tiny footnote that basically said that they got the idea from a photo from another institution. They didn't credit Franklin or her institution at all besides that. So, who really invented it? There's two sides to this coin, because you can say, okay, Franklin did all the lab work, she deserves the credit. Then you have people who say, well, Franklin did the work, but Watson and Crick beat her to it. And it's not like they completely stole the work. They saw the photo, they knew what it meant, they drew up the same drawings, and then they turned it in. So they did a lot of work too. I would say you can put it anywhere on a scale of who should get more credit. However, I at least believe that Rosalind Franklin should have gotten more credit than she did. She ended up actually dying very young because of all that X-ray exposure. So, I don't know. That's up to you, and I'm going to let you contemplate that idea in your responses today on your Google form. Here's a photo of photo 51, by the way. I know it's not very easy for us to tell what it means, but at the time, the researchers who were all over this, oh my goodness, this was like $1 million photo for them to get. Rosalind Franklin did a lot of great work here. All right, so now as we are finishing up, let's review here. We have Antony von Leeuwenhoek. He goes with microbiology in the microscope. You have Edward Jenner. He discovered the vaccine. And then Watson, Crick, and Franklin are all associated with the double helix or that DNA. Okay? So, as always, here are my sources. Let me move my face so you can see them all in case you would like to visit them. Here are my sources. And that is all I have. I'm going to put my face back up here. So what do you do now? Just like in our first lesson, you have a Google form to answer about the inventors of science and medicine, so you're going to fill that out. If you need any help, you can ask your teacher, or you can ask me on Twitter at juliapucci.edu, or you can visit my website and find my contact information there. If you have any technical questions for your friends, you can ask them that too, but don't ask them about content for your homework, please. All right, that is all I have for you now. Have a great rest of your day, and I will see you in the next lesson. Thanks. Bye.